Hey everybody! Purpose of this video is to get you some solutions to this quiz here about the UN predicting world populations. So it says using the tool from the quiz above. So let's look up at the quiz above. Oh yeah, this guy right here, this Desmos site. Yep, let's pop that open. Whoops, let's not do it that way though. Let's do it this way. Alright, so this is going to help us graph our logistic regressions on this data. Alright, it says for logistic model for the world populations in billions, so that's going to be your output variables 1 through 9. Let's see if I can put those in first. Let's see if I can do this. Oops. 2, 3, 4, 5, 6, 7, 8, 9. Okay, beautiful. Now all I gotta do is go back and put the years in. Let's go look at that. So let's see. We've got 1804, but yeah, you want to go years after 1800. And the reason for this is it's a mathematical one. The logistic model needs to kind of start quote unquote close to 0 with both x's and y's. Otherwise, it gets upset, or you have to phase shift it, which maybe some of you'll study that at some point in later stat classes. So it looks like 4, 127, 160, 174. Let's get that far. 4, 127. Shoot, I forgot it already. 160, 160, 174. And as you see over here, as we're doing this, things are starting to update, which is kind of fun. 187, 199. Oops, that one goes there. 187, 199. Okay, you're starting to see some behaviors over here. 211, 224, 242. 211, 224, 242. There we go. Okay, now I'm going to have to squish this window a little bit to make sure I get everything right. Yep, I'm going to have to squish this window, I think, to I forget how to do this. There we go. That's not bad. That's not bad at all. And if you really squeeze it in, you begin to see it. It's over here. There it is. So there's your logistic. I forget how to stretch just one axis. I've forgotten how to do that, but it's okay. I mean, I think you can see what's going on. If I can I can't just grab that and pull. Anyway, back to the quiz. As you know, the data, there's a smooth curve. The predicted populations match the data, the actual population. So your data is green, and then the curve keeps going. All right, let's take a look at that again over here. Yeah, it does pretty well actually. We can zoom in on this part of it right here, but look at that. I mean, it's keeping up with it pretty nicely, showing it continue to grow, which I think makes sense in a lot of ways. Okay. Why does the logistic model make more sense than an exponential one? And I gave you a hint to look back to the previous quiz, and hopefully the point of that quiz was clear to you, unless you didn't do the quiz, in which case you had to go back and read about it. But the point is that the logistic model ceilings, it begins to creep up to a limiting value that you can't get past. And that's the point of a logistic versus exponential. Exponential keeps growing at whatever average rate you get. So if it's like in the previous quiz, in quiz 3, it was a doubling. It was a 200% growth over each time period. That's fine to a point until whatever you're growing runs out of resources and then can't double anymore. So in that one it was a class rumor, and this one it's the population of the world. But in this one here, you're seeing it begin to ceiling off past, let me see, let me go back to, it's here. It looks like it's beginning to ceiling off right there. So it's growing pretty exponentially up to a point. Like it's got this nice little curve going right here. I really wish I could figure out how to zoom in on just, and I can't. Nope. I can't, so it's okay. No, I'm looking here. Sorry, here we go. Here we go. Let's change the y value to 10 and the y 0. All right, 0. Okay, this is going to look better, I think. And then we can zoom out. Ah, there we go. That's much better. That's a much better look. Okay, so now you can see the model, the black model here. It actually underestimated the population back in 1804, which is totally fine. It's a model. It's not perfect. But then it begins you begin to see the exponential growth kick in, but then there's this inflection right about here. It looks like right about here it begins to slow down. As a matter of fact, the model is growing a little bit faster than the actual population right about there. So, good. All right, I'm glad you got to see that troubleshooting that I just had to do. I completely forgot how to adjust the windows, and I just decided to start clicking around and looking. What should the human race's population have been at the end of 2017 according to our model? Okay, well, let's look. According to our model, let's see. 2017 would be 217. 217 right about here. It looks like 7.3, 7. Somewhere in 7.2 or 7.3 billion people, and then I actually checked it. 7.6 is estimated to have reached 7.6 billion as of December 2017. Okay, the United Nations estimates it will further increase to 11.2 billion by the year 2100, which would be out here at 300. Let's take a look and see if they're using the same model we are. 300. They must be using a slightly different model because we've got about 1 billion more than that, 1.5 billion more people than that. But that's okay. I mean, these are all models. They're not perfect. Models don't let that belief that just because you have a model you have a perfect answer. What is the apparent carry capacity of this model to the nearest billion? It tends to level off at what number? Well, let's just take a look here. Grab it and pull it this way. It looks like it's starting to level off. Right about here, it's creeping up on what? That looks to be about, what, 15 billion people, I think. Yeah, after past a point, it doesn't matter how far you go. It's not gonna gain more than 15 billion, which is double what it is right now. Okay, using the non-predicted data, verify my claim that the human race doubles approximately every 40 years. That was an extra point question, so nobody tried it. I'm going to leave it out there. But it's similar to what we did in class, because the idea of it doubles approximately every 40 years using non-predicted data. That's the idea there, is you're using the stuff we actually have in front of us. So, at any rate, I hope that helped. I'm glad we got to see me problem solve through the window. That was fun. I enjoyed that. Hopefully you did too. And we'll catch you in class.